Next time you're with a group of friends and you have to go pee, be a little fancy. Stand up and announce to them that I must now undergo micturition. Micturition, which is a fancy phrase for to pee or to urinate. And so in this video, we're going to talk about the process of micturition. Beginning where we left off in the kidney, after we concentrate urine in our nephrons, we have this part that sort of touches the tip of the renal medulla. That's our renal calyx. Our renal calyx will be the part to first collect urine from the collecting tubules. And we said several renal calyces coalesce together into the renal pelvis. So that's the renal pelvis right there. And then the renal pelvis itself leaves the kidney through this tube called the ureter. The ureter, and we've got two ureters right there. The ureter then conducts our urine inferiorly, or towards our feet, by connecting into the bladder. And note that these dotted lines imply that the ureters attach to the back, or the posterior aspect of the bladder. So our ureters are like a one-way street because they have valves that prevent backflow of urine upwards. That means that the urine will only flow down towards your feet. But there are certainly some exceptions to this, which I encourage you then to think about what could happen. What could happen if you allow urine to sort of flow backwards instead of in one direction towards the loo or the toilet? And we'll talk about that in a minute. But for now, from our ureter, our urine makes it into the bladder that I've drawn right here, and you can see it from the front like this, but it may be useful to take a look at it from the side. So if I say this is the top, and then the bottom is over here, and our anterior side, or the front on this side, and our posterior aspect, or the back, on this side, our bladder would look like this. It would have this top right here and then kind of spin down like so. And this front part right here would be kind of pointy. And so this comes down and collects here. And don't forget that our ureters conduct urine to the back right there. So I can draw two of them, these guys right there. And this is our posterior aspect. And the fancy thing about our bladder is that it's lined with something that's called transitional epithelium, which is something like what you've heard of before. You may have heard of squamous epithelium, which is just flat epithelial cells, or columnar epithelium, which are taller cells. Transitional just means they're somewhere in between. And the reason why we do this is because it allows the bladder to expand. Remember, the bladder is going to be filling up with urine and holding on to it until we're at an appropriate place to go to the bathroom. So until then, our transitional epithelium allows our bladder to fill up and hold about 300 to 500 milliliters of urine, which is about the volume of a tall bottle of water. This then leads to a structure down here that I'll draw going that way, and I'll draw it here as well, that goes straight into the loop. This final part of our urinary tract is called the urethra. The urethra. And we don't just have urine leak from the bladder and go straight into the urethra. There's some control here. At the neck of the bladder, right about there, we have what's called the internal, because it's deep inside us, the internal urethral, because it surrounds the urethra, sphincter. That's the internal urethral sphincter. And it's just a circle of muscle that is not under our control, but it makes sure that the bladder keeps urine within it and doesn't leak out urine unless it's really full. And so we don't have control over the internal urethral sphincter. So if you were to guess what type of muscle this is, I'm sure you'd say this certainly is going to be smooth muscle. Smooth muscle because it's involuntarily controlled. And just for reference, that sits about right there. So that's going to be our internal urethral sphincter. So now that we've covered the bladder, I think this would be a good opportunity to take a look at a video within this video that shows how the ureters spray urine into the bladder. We call this a ureter jet, and sometime you can see this on ultrasound, like here. I've oriented the ultrasound like this. You can kind of take a look at the top and the bottom of the bladder, but some of the rest of this image may be a little different, but just focus on the bladder for right now. And let's play this video. Oh, and I should mention that this thing right here tells you how much flow that you have. So notice whenever you see anything in yellow or orange, that just means that's urine that's being ejected into the bladder. So as I press play, notice that we have one stream that fires in, that's one ureter. And then when that stops, we're very lucky to see another ureter right there fire some urine into our bladder. I got this video from one of my mentors, Dr. John Fox. It was very nice to lend me this. Going back to the cartoon world that we have here, we can focus on what happens once urine leaves the bladder and goes into the urethra. The urethra will conduct urine to the outside world, and that's the organ that we use to pee away our urine, but the path from the bladder to the bathroom is very different if we're talking about men versus women. So I've got this female bladder right here that's going to lead into a female urethra that we're going to talk about, and I'm going to contrast that with the male urethra. Now, to be complete, the female urethra has sort of the same setup as the male urethra. It leads out of the body and has its own internal urethral sphincter right up there. And then there's a part of the urethra that happens afterwards right here that's called the membranous urethra. So membranous because we pass through a membrane or a sheet that circles the urethra. And so we've already talked about something that circles the urethra already, and that's kind of right above the structure I'm drawing in right now. We had the internal urethral sphincter that was circling our urethra at the neck of the bladder. Down here, this membrane or this sheet that we have sort of circling our urethra is the external urethral sphincter. And because it's external and it's something that we control, this is going to be made up of skeletal muscle. Skeletal muscle, and this is what we learn to control through potty training. Now, to contrast that with the male situation, we don't go directly into the membranous urethra. No. Instead, we have a portion that's called the prostatic urethra. The prostatic urethra because we pass through an organ called the prostate. It's not directly involved in the urinary system, but it circumscribes the urethra right there. After the prostatic urethra, then we have the membranous urethra. So that's the part that's the same as what we've got in women. So we have our membranous urethra. And of course, in dudes, we've also got this sheet or this muscle that's surrounding our urethra here. That's our external urethral sphincter that's under voluntary control because it's skeletal muscle. And then from there we lead into what's called the spongy urethra. The spongy urethra is just the part of the urethra that's in the penis. So that's in the penis, and then afterwards the urine leaves the body and it's out in the external world. This entire system right here is in contact with the external environment. Now, as you may have guessed, women don't have a spongy urethra. So what happens after the membranous urethra is actually kind of short-lived. This is actually going to be pretty short in comparison to the male urethra. So the connection to the outside world is a little more direct in females than it is in men. Now this kind of goes back to that comment I made earlier about backflow. We make sure that our valves here in the ureter makes urine go in one direction to the bladder, and then we're going to go out this way. But if we don't have valves and we do have backflow, we can end up having what's called stasis, or urine just kind of hanging out up here or maybe up in the kidney for a long period of time. Now that can be problematic, especially because we're in contact with the external environment. And you know that there are things like bacteria and viruses and fungi that can cause an infection. So if we have stasis right here, I'll just write a little telephone pole right there, stasis right there, we may have a greater risk of infection. Greater risk for infection because one of the functions of urinating is also to dispel bacteria that may have made it up the urethra from contact with the external environment. So we have a greater risk of infection if we have backflow, and we have a greater risk of infection if we have a shorter urethra, which is what happens in females. And that's the whole reason why women tend to have more urinary tract infections. So I'll write that down. That's a urinary tract infection, a UTI. They happen more so in women than they do in men because women have a shorter urethra. Either way, the urine makes it out of the body, goes into the loop, and effectively discards the waste products that we've made in our body that we've filtered and concentrated in our kidneys.